now let's talk about what is AI, ML, and DL. And Salam, you had asked me yesterday about that, so I have a slide just for you. So, and I'll tell you when you were asking me how it works, so I was like, okay, I'll put that in there. So hopefully that will be useful. So let's get this terminology correct. As I said, what is AI, what is deep learning, what is machine learning, and it's being used very loosely and synonymously. So let's first say, what is artificial intelligence? So that involves machines performing tasks that are characteristic of human intelligence. But let me make something very clear. Right now, the stage that we are in, these tasks, these deep neural networks, they are performing, or AI is performing tasks to a very specific thing. It does not have common sense right now. What we call artificial general intelligence is decades, if not hundreds years away. So these killer robots, they exist only in movies. There's a lot of hysteria and panic over that, but probably unfounded. But there are issues, and I'll talk about that in a bit. So machine learning, now artificial intelligence is the global, all of this fits into artificial intelligence. What is machine learning? Machine learning is a subset of artificial intelligence. And as defined by Dr. Andrew Ng, who, by the way, is a pioneer in this area, and I've had pleasure of listening to his lectures, and I recommend you to check it out in Coursera. So the way he defines it is that it's the science of getting computers to act without being explicitly programmed, which means the learning, right? It says machine learning. So there is this learning aspect that these machines are learning on their own. You haven't told them to do exactly what to do. And then deep learning is a subset of machine learning, and that involves a lot of data and neural networks. And this is the slide that I was talking about. So I've tried to simplify it, but there are two concepts, major concepts in deep learning. One is training, and the other is inference. In this case, the job of the deep neural network, which is the center, these neurons, the circles, and then you have interconnects with weights. So that's the deep neural network in the middle. The job of the deep neural network is to classify the input images that are coming in, into one of these three categories. In this case, it's either a human, or a bicycle, or a strawberry. So these input, this data that's coming in is labeled. That means it already knows what this is. And so in this example, a bicycle is fed into this deep neural network. It goes in, and the model, first time, incorrectly, because it doesn't know what it is, it incorrectly identifies it as a strawberry. Now, this information is propagated back, this error, propagated back into the deep neural network. The weights are adjusted so that the next time this image is passed on, it will identify it correctly. So this part of training goes on and on. Lots of labeled data is tagged data is fed into this model until it reaches the desired accuracy. Once that happens, your model is already trained. And then you're going to use it for inference, which is the second set. So the training involves a lot of compute power, and that's typically done in data centers. Inference, however, the second part, that can be done on your smartphone, or of course it's done in autonomous driving, etc. Okay, so I hope you get these two concepts clear, because this is the basic of deep neural network, which is a subset of machine learning, which is a subset of AI. So how to get started? As I mentioned before, that there is a lot of open source work that's happening. So this is a portfolio of Intel, and it has a very broad portfolio. So let's start at the bottom. So at the bottom is a list of hardware that Intel has. So we have data center, we have general purpose CPUs, we are building deep neural network processors, we have FPGAs. So depending on what the customer wants, whether latency is important, performance, so we have the hardware. On top of that, you have the software, depending on the user. If it's a library developer, we have compilers, so we build the software. And then in the middle row, at the right, you see the deep learning frameworks. So these are open source frameworks. So for example, TensorFlow, developed by Google, MXNet, developed by Amazon, Caffe2, PyTorch by Facebook. So my team works with all of these companies very closely because we are basically optimizing it so that it works on Xeon. So my point of showing this is that there is a lot of collaboration happening. All of this is open source, especially in the area of AI and deep learning. People are putting their models on GitHub. Like my team has lots of trained models. We're there for anybody to use. And papers are being put in archive. So you don't need to start from scratch. Look at the resources that are already out there. Use that. Use examples. Take advantage of that. So here's a resource that you can use, software.intel.com. There is a lot of tutorials. There are tools. There are webinars. And take advantage of that. And similarly, there's a lot of it available. So take advantage of that, learn, and use it. And it says time is up. And I'm going to leave you with these three key thoughts, takeaways. The one is that AI is advancing rapidly. And it's poised to remake the world. But beware the hype. Some of it is unfounded. Some of it, like job disruption, is indeed something to think about. Learn to leverage. You don't have to start from scratch. There is so much work that's already done. Take advantage of that. And finally, use in an ethical way. So understand the limitations and use it to uplift mankind. Thank you very much.